Here with this video, we're going to continue to look at using our U substitution, but this time we're going to use it with our definite integrals. And we have our change of variable for definite integrals. Basically states if we have our function again, we're going to let u equal some function of x, and it has to be continuous on our closed interval. And of course, function f, as before, has to be continuous on the range of function g. So if you notice here, we have our composite function as before, f of g of x, and then we need to have our g prime of x, so that's our du. But notice here, when we integrate this, we're looking at our variable is in terms of x, which means our upper and lower limits are in terms of x. So when we have a definite integral and we change it using our u substitution, we change our variable into u and du. So we then have to change our lower and upper limits into u values instead of x values. So I want to look at an example here how we can do that, and I'm going to look at this example two ways. First, I'm going to look at it how we can continue to work with this using our x values as our limits -2 to 4, and then I'll go back and look at what we can do if we want to leave it in terms of u. So we have x squared multiplied by x cubed plus 8, the quantity squared, dx. So we're going to start out, and we're going to let u equal the inside function, just as always. We'd have x cubed plus 8. And then we could take the derivative of u, and we would end up with 3x squared dx. And we'll notice here that we have the x squared and the dx in the problem, but we're missing the 3. So since that's only a constant, we can multiply by 3 and then a 1/3 out front. So it's really the same as we did with our indefinite integrals, except for we're going to have to do a little bit something different with our limits. So I'm going to bring down the 1/3, and we will have the integral of our x cubed plus 8 squared, and then we would have our 3x squared dx for our du. So if we do the actual substitution here, we would have 1/3 u squared du. And once again, it becomes a very simple integral problem. We would then have 1/3, and let's see, I forgot to bring down my limit, so this would be -2 to 4. And you're going to notice here, once I change this to u squared du, I'm not going to put my limits here because now the limits that we have -2 to 4 are x values, and now we have changed this in terms of u. So I'm leaving these limits here out for right now on purpose because they're not -2 to 4 because those are in terms of x, and now we have our function in terms of u. But we can still integrate this, so that would just simply be we have our 1/3 multiplied by u cubed over 3. Okay, and I still know we're going to have limits here, but notice I'm not going to write those in. And there's our integral, and notice again we have limits, so we don't have a plus c. But now I want to resubstitute this back in terms of x. So we would have 1/3 multiplied by our u, and our u is x cubed plus 8. So x cubed plus 8. And that would be quantity cubed over 3. Now, at this point, I can think of this as plugging in our limits, where we would evaluate this from -2 to 4. So we could simplify this a little bit and make it x cubed plus 8 cubed over 9, -2 to 4. And at this point, you would simply plug in your limits. So if we plug a 4 in, you're going to end up with plugging in the upper limit, 41,472 minus, and we plug in a -2 here, If you cube a negative 2, you're going to end up with a negative 8 plus 8, so all of that's going to go to 0. So our answer is 41,472. Okay, so that's one option. The other option to this problem is, once we get to this point here where we do the actual u substitution, if we have 1/3 integrated the integral of u squared du, then there's one way we can handle this, and we can say, all right, we're going to look at our lower limit and realize that our lower limit over here is an x value of a negative 2. Well, we know that u is equal to x cubed plus 8, so if u is equal to x cubed plus 8, then that means our lower limit would be u is equal to our x value of negative 2 cubed plus 8. So therefore, when we look at this, then u is equal to, of course, negative 2 cubed is going to be negative 8 plus 8, so u is equal to 0. So therefore, our lower limit becomes 0. Now, we've changed it over here from negative 2, which is an x value, to our u value. Then we can look at this and say, all right, for the upper limit, we know u is equal to x cubed plus 8, so we're going to plug in the upper limit of 4. So we would have 4 cubed plus 8, and we end up with u equaling 72. So the upper limit now becomes 72. So now, once we integrate this, we would have the 1/3 out front, and then we would have u cubed over 3, and then our limits would be 0 to 72. Now, the advantage of this part is we could just leave this now in terms of u, so I'm going to go ahead and multiply by the 1/3, and we have 0 to 72. Now we don't have to resubstitute because we changed our x limits into limits that are in terms of u values. So now we can plug in the upper limit, and we plug in 72 cubed over 9, you're going to get the same answer of 41,472, because of course if we plug in 0, we're going to subtract away 0. So here you can work this problem two ways. We can leave it strictly in terms of x, but if you use the x values for your limits, you must resubstitute your u back into values of x. If you don't change it, you can leave it in terms of u, but you must change your limits from x values to u values. So that's pretty much the only difference here if you have a definite integral as opposed to an indefinite integral using your u substitution. All right, my next example here, just as a review, we've looked at solving differential equations before, but we haven't looked at a whole lot of these, so I want to look at another example just as a reminder. We have a differential equation, which simply means we have variables such as the derivative of y, and we have x values, so we have different variables here. So we could start out by solving this by rewriting this as our dy is equal to 10x squared over the square root of 1 plus x cubed, and this here should be a 1. And if we move the dx over, we could write it this way. That's kind of our alternate way of writing this. And now we could simply integrate both sides. And of course, if we integrate dy, that's going to simply be y. So now, how are we going to integrate 10x squared over the square root of 1 plus x cubed? Well, of course, we're going to use our u substitution. We can let u equal the 1 plus x cubed. And if we take the derivative of u, we're going to end up with 3x squared dx. Now, this is kind of neat. We haven't looked at one quite like this. We have the dx, we have the x squared, and we have a 10, but we only need a 3. Now, probably the best way to handle this is to rewrite this and say, all right, we have the x squared, we have our dx, and we have the square root of 1 plus x cubed. And the 10, because we don't need that, we can actually take this 10, since that's a constant factor, we can move it out in front of the integral. So then, what do we need? Well, we're missing still the 3 for the du, so I could multiply in here by 3 to get the 3x squared. But again, if I multiply here by 3, that means out front I have to multiply by 1/3, so that means I'm going to divide by 1/3. So now we have our integral of 3x squared dx, which is all du, and on the bottom we have the square root of u. So if I rewrite this, we could think of this as 10 over 3, the integral of the square root here. We could bring this to the top. We could think of raising 1 plus x cubed to the 1/2 power, and if we move it to the top, it becomes 1 plus x cubed to the negative 1/2, because we're moving it to the top, so it makes it a negative exponent. And of course, we have the 3x squared dx, and keep in mind all of this is our du. So if we perform our substitution, then we're going to have 10/3 the integral of u to the negative 1/2 du. So we would have 10/3 multiplied by u to the negative 1/2. We increase that by 1, so that becomes u to the 1/2. And keep in mind, we could divide by 1/2, or if we multiply by the reciprocal, we can just simply multiply by 2. And we don't have limits because this is an indefinite integral, so we would have our plus c. So then we could actually multiply this, and we would get 20 over 3. 10/3 times 2, we get 20 over 3. And then in place of the u, we know that is equal to the 1 plus x cubed to the 1/2 power. So once again, we want to change the answer back in terms of the original variable x. So that tells us y is equal to 20/3 times 1 plus x cubed to the 1/2 plus our constant term.